Okay, welcome everybody. Time for the Secure Single Page Applications webinar. My name is Ideskog. I'm the CTO here at Curity. I'm going to be joining as a Q&A participant in the end. I'll hand over now to our identity experts here, Gary Archer and Jonas Iggbom. And welcome everybody.
Hi.
Yeah, thanks, Jacob, for the intro. So, as Jacob mentioned, we're joined with Gary. We're going to talk about security for single-page applications, and we'll start with some background and details on the threats that we're dealing with here. We'll introduce the token handler from Curity and that pattern and what that looks like. We'll follow that with a demo that Gary's going to do, mostly around sort of how you integrate the token handler with your single page application. And as Jacob mentioned, we'll follow all of that with a Q&A session at the end. So please submit questions as we go along here. We'll probably take a few of the questions along the way as well. But with that, we'll start with Gary covering some of the backgrounds on the threats here.
Hi there, yeah. So I think the main concern these days in single-page apps, the main security concern down in the browser is the threat of malicious JavaScript. So if malicious JavaScript can run, it can do anything your application can do. It has access to any data exposed to JavaScript. So this is often called cross-site scripting or XSS. And the two of the main causes are compromised JavaScript dependencies. So for example, if you've got a single page app that uses Angular or a technology stack like that, it typically brings in a large number of third-party dependencies. And if any of them get compromised, then you've got a cross-site scripting vulnerability.
Yeah,
so,
fun fact there, Gary. I did a check just a few days ago on the React Next.js. If you just create an empty project with those two, you get 360 dependencies. So
nice.
yeah, it's quite a lot.
So obviously, yeah, there are best practices. I know that, OWASP has a cross-site scripting prevention cheat sheet. And so you should definitely try to, do everything you can to avoid cross-site scripting vulnerabilities. But like I say, dependencies are one of the big causes. Sometimes developers don't handle input correctly or whatever, but probably you should assume that at some point there might be a cross-site scripting vulnerability in your app. And so one of the big things that you should try to do these days is to limit the impact of any XSS vulnerabilities. And that's a large part of what OAuth for browser-based apps should do for you. So in terms of the environment we're talking about, we're discussing OAuth and OpenID Connect secured single-page apps. And this often starts with the following type of solution. Developers implement a single-page app. They implement a authorization code flow to get tokens. And then in the JavaScript code, they make API requests using those tokens. So this provides a pretty productive architecture. It's relatively simple to code, but the problem is that there are vulnerabilities in those tokens. There's the chance of someone exfiltrating them, for example. Here's an example that Jacob provided recently, and in this example, there's some malicious code that's executing, and it's updating an image URL. And that image URL is reading local storage. And what you often find is that developers, in order to get things like their single page app working reliably with tokens, is they often store tokens in local storage or something like that. But there's many techniques where malicious code could potentially intercept tokens. For example, malicious code can register an event listener. It can use monkey patching or various techniques to, get hold of anything exposed to JavaScript. And if someone is able to exfiltrate tokens, they can potentially send them to a malicious site and mount a really concerted attack against your APIs. So this is what you shouldn't do, basically. So using tokens in JavaScript does open up many threats. And you can read all about these. There's a document called OAuth for browser-based apps that goes into a lot of detail about the threat of malicious JavaScript.
But wouldn't CSP headers prevent that attack, though, from exfiltrating the tokens and sending them off specifically to another site? Or how does that work?
I think it, obviously a strong content security policy is recommended, but it's like sometimes there can be windows there. We find like, you're using a content delivery network or something, and therefore you open up the content, therefore you open up the content security policy to allow additional hosts. There's even possibility sometimes, I believe, that users can disable the content security policy. So CSP has got some problems. It's not perfect. Did you have anything to add to that, Jacob? You probably got a stronger understanding. Well, one of the strongest understandings here. But
no, I mean it's a good point. I think CSPs are necessary. You always need to use them and set them in your so that you declare where you can pull sources or get things from. But like you say, you have to always think of everything, and it's very easy to overlook that certain parts are open because you're loading images or you're doing, you need to poke holes here and there, and then all of a sudden it's open, and that can be exploited.
That's it. Yeah. And because a token is, something that JavaScript can get hold of, that does open up a lot of vulnerabilities, and it's specific to the browser environment, which is a hostile environment, right? So Jonas, you're going to give us an overview.
Right. Before we move on, I would like to add too, like it's a balancing act, right? I mean, you can have a super tight CSP policy, but that might make other things that you need to work unusable, right? So it's a balancing act between usability and security in that regard.
Yeah.
I would like to also cover a question that we just got in here, since it directly relates to that example that you had on the previous slide. We're using local storage in that example, but the question is, what about session storage?
Yeah, I think as I said, there's various ways of intercepting tokens. I mean, you may even think that storing tokens in memory is secure, but an attacker can if you can execute malicious code, you can do things like override the fetch API, the browser's built-in fetch API, to intercept tokens. So there's many possibilities. So none of it's really safe. Using tokens in the browser at all opens up extra threats.
Yeah. Right. The JavaScript has access to loads of different storage mechanisms, right? So it's about the JavaScript having access to these different storage mechanisms to be able to exfiltrate the actual token.
Yeah.
And a token can be, if you get hold of the token, it can be used pretty much wherever, right? You can take that token and use it in other applications or what have you.
Yeah, and it gets worse if you have the refresh token in there as well. I mean, then you could be a long-lived attack. And it's easy also to forget that the attack doesn't have to be getting the token when it's stored in the browser. I mean, if you can get a token by calling SSO in an iframe, so can an attacker. Even if it can't see the token, like you said, it could monkey patch the fetch API and catch it when you're using it. And so if it's there, it can be stolen. I think that's the conclusion, right?
Yep.
So that leads us back to a good old-fashioned cookie. So Jonas, you were going to give us a brief overview.
Right. So, I mean, all of this and what we just discussed here, it essentially boils down to that the browser is a very hostile environment, right? There's a lot that can happen within the browser. So there's some things, not necessarily super recent, but there are some defenses against protecting, or there's some mechanisms to protect cookies. And one of the major aspects here to protect against the JavaScript having accessibility to this is to leverage HTTP only cookies that then does not allow the JavaScript to access the storage, right?
Yeah, and then that
So
eliminates a large class of threats, doesn't it?
right, you've cut out a lot of attacks in that. Probably like not everything, but you've heightened the security significantly by not allowing JavaScript to access these cookies, right? Also, this allows the cookie attacks to it mitigates the cookie attacks to happen when a user has sort of navigates away from the site or close the browser, right?
And that's a very important point, because if there's a token stolen, that can be living in a curl command somewhere for as long as that token is valid or the refresh is valid. Whereas a cookie-based attack, if you're writing a session in the browser, that dies when the user closes that. So
Right.
big difference. Yeah.
Yeah, so there are some inbuilt protections, aren't there? And so I suppose, Jonas, it leads to this type of solution that's, I guess, many people are familiar with.
Right. So the backend for front end pattern that we can call it, or mechanism or architecture, where we can let a backend for front end component issue cookies that are set to same site strict, or with the same site strict property, for example, where we limit the application to only leverage these cookies in the SPA, right? So the cookies cannot be used by any other domain, for example. And in this example here, there's a backend for front end running on an API gateway that handles the OAuth flow. And instead of passing a token to the single page application, we issue, or a cookie, a secure cookie is issued to the single page application that can then leverage this cookie as its token, right? So we don't store a token in the single page application. We actually issue a cookie that represents the token. And we can go into sort of details on more of what that look like and what that backend for front end component does. But this leads into sort of the what we call the token handler pattern, right? Which is that BFF that runs on the gateway there,
and
together with other components.
It's a good point you raised there about the same site strict as well, Jonas, because I think in recent years cookies have become stronger as well. You know, the use of cookies across websites is no longer permitted, which is a good thing for security, right? Because it cuts out a class of, quite a large class of cookie threats that used to exist. So cookies have become quite a bit stronger in recent years. So as well as not allowing access to JavaScript, they also have better protections than they used to have, right?
Exactly. Yeah.
Yeah. I mean, the same site is a good protection mechanism also for the what's called the CSRF attacks, right? Where you fool the user to click a link that takes them into the application where there's perhaps already an active session, and then it does something on that session. Whereas when safe site strict is set, you can't do that. The browser won't send a cookie in that case if you're just following a link and hitting the site like that. So it's additional benefits beyond just what we're discussing here with XSS.
Cool. And so I suppose, what is the token handler pattern? Is exactly what do we mean by it? And so when you're implementing cookie security into your SPAs, obviously you want to avoid mistakes, but there's some hidden complexities about cookies as well, because I suppose the traditional way of doing cookies has been to use a website. But if you're a single page app developer, or if you're building single page apps, you don't really want those behaviors you used to have in websites. You don't want the big complex web host to run on a development computer. You maybe want to continue to deploy your single page app to a content delivery network for the best global performance. And you want the single page app to retain the usability control, all of these things. Sometimes in the past, developers would struggle with the interplay between a back end and front end of a website and making it behave nicely. So you sort of want to integrate the security in a way that serves your single page app architecture. So that's the goal of the security solution, which Jonas is going to explain the key points of, I think.
Right. So this is released. Well, it was released a while ago as an experimental feature, but we actually released 9.3 yesterday, where we now include the token handler. So this is exactly that, right? What Gary was just talking about. It's a BFF component combined with another component. We'll look at both of these pieces in a little bit here, but it's a plugin professionally developed OAuth and cookie security component that works with obviously Curity, but also with any standards-based authorization servers out there in the market that are following the OAuth and OpenID Connect standards. It's developed by us. This is what we do all day, every day. It's maintained by us. It's supported by us. And with that, you get design and guidance on how to deploy this and how to make this work for your single page applications. You obviously get professional support and professional services from Curity as well, as an option, because this is a supported product from us. We've done some of these components in the past more or less as open sourced, but now the token handler is an officially supported product that we deliver.
Yeah, and it's I think what's interesting as well is in some ways it's kind of a black box, but we want you to understand the main concept. So we provide good documentation and examples and things to help you understand it as well, because obviously it's your SPA, you need to understand its cookie security, etc. So this is,
but it is also a black box in the sense that you kind of don't have to worry about you don't have to worry about implementing the code that handles cookies or issues cookies and whatnot. That's taken care of by us, and we know how to do this well, right?
Absolutely.
And so the token handler pattern, we've seen a brief preview of this a little bit earlier, a couple of slides ago, but the token handler is the BFF in this case, but it's comprised of two components, right? It's got an OAuth agent and an OAuth proxy. But these here look like they're co-located. They don't really have to be, and they probably won't really be, because the proxy is the component that runs on some kind of API proxy, API gateway, where we provide those plugins for the different API gateways in the market, the main ones, and we can probably develop more as needed if new gateways pop up. The agent actually, in our case, runs on a Curity controlled server, a security identity server instance, where you don't have to have the full-blown Curity product. You can actually run the OAuth agent separately. This is the case if you have other authorization servers that you use.
Yeah, so token handler is that bit in the middle, isn't it? You basically configure and deploy that bit in the middle is what you have to do in order to use the token handler pattern, and everything else stays the same. And this way you get professionally reviewed cookie and OAuth security implemented for you. And it's pretty much just a deployment job. There are some small code changes in the single page app as well, but they're minor.
Yeah, and so here the agent really takes care of sort of the OAuth flow in a sense, right? So the agent handles the OAuth flow and receives the token, and then is responsible for issuing the encrypted cookie that gets returned to the single page application. And the proxy then is responsible for handling sort of what do we do with the cookie when the SPA needs to talk to the API, right? Because the SPA can't read the cookie or can't handle the cookie. So the proxy is responsible for decrypting this cookie so that the token becomes accessible and can be passed upstream to the API. So now outside in the single page application, there's no cookie, or there's no token. There's a cookie, and the API actually receives the token in kind of whatever form that is, JOT or opaque token or whatever it needs to be.
And it's always worth mentioning, isn't it, that the domain security stays within your APIs. And so your API still need to use JOT access tokens and apply claims-based authorization, which I imagine everyone's doing already anyway. So, but so all this is really is this kind of a translation layer, isn't it?
And the API doesn't have to change, right? Like the API still operates as normal. It's gonna get a token.
Yeah. I'd like to think of the OAuth agent really as if you think of a traditional website with a backend where you have most of the client logic implemented on how to get the tokens, how to use them when you call the API and so on. I mean, that's what the OAuth agent is. It's really the one who gets the tokens and does it in a secure backend, except it's general. So you can use it with any SPA. You don't need a custom backend now for your single page application. To do that, you could just have a BFF that is configured for your application, and that's it. So that's what the BFF pattern and the token handler pattern in general is trying to achieve, right? And then the proxy handles, like Jonas said, the API side of things.
The agent will really do like a heavy lifting, right? I mean, you kind of extract that from having to do that in the application itself. The agent will take care of a lot of that, and it sort of, in a great extent, simplifies the application.
We have a few questions here. Should we inject those here? Doesn't the BFF concept make things like auth guards unusable, thus limit common usability requirements? I imagine that's referring to Angular auth guards. I think that is, if I answer that one, I think that is orthogonal. So no, it won't affect that because it's like any backend and cookie communication. So as long as there's a domain that matches, the cookies will flow. So it doesn't come into play like that. Unless you have something else to add on that, Gary or Jonas.
No. What I'd say is a big thing about the OAuth agent is to put the single page app in control. So it tells the SPA what to do, but the SPA does it itself. So if an Angular app wants to know if a particular path is valid or whatever, it can work it out based on what the OAuth agent tells it. So based on its own knowledge. Right.
Another question here. How often should the BFF cookie be renewed to the client? Today we have 1 minute. We are thinking about 10 seconds or something. What is the right value here?
I think, I think we tend to sort of follow OAuth semantics. I think for this stuff that the cookie represents, the main cookie is the one that you send to your APIs from the single page app. So that represents an access token, and so I would say it's
whatever the access token lifetime is a good cookie length. And then you can, of course, do you want them to be persisted in the browser or session based, so that when you close the browser, the cookie disappears. I mean, that's something to think about in this pattern, obviously, but that's the general rule. The lifetime is the length of the access token.
Yeah, so I like to default to I think in the Curity product we default to 15-minute access tokens, and I think that's a good default. And the HTTP only same site strict cookies that we send, by default with the Curity identity server, they'd be 15 minutes. You can change that time as required. And probably I want to talk a bit about the experience aspects. So when I mean experience, is sort of the good things you want about single page apps. So the OAuth agent enables the single page app to use API-driven OpenID Connect. So what that means is that the single page app, for example, it asks for its authorization request URL, but it doesn't get abruptly redirected or whatever by the OAuth agent. So the single page app retains usability control of expiry events, when redirects happen, that sort of thing. Single page apps continue to use a web static content host. And there's a few advantages to that. One of them is it keeps your developer setups quite simple, and developers don't get bogged down with cookie mechanics or anything. Also, you can deploy your single page app to a content delivery network if you want to, which gives you some global performance benefits. And you don't have to, route your API requests via a web host or something like we did in the old days with websites. Instead, the single page app makes direct requests to APIs that validate JOT. So as I said before, the token handler pattern is very much about serving the single page app and maintaining that experience that you probably care about. So what are the integration steps in effect? So Curity OAuth agent it's a stateless API basically. So you can cluster it, you can deploy it as a Docker container or virtual machines if you prefer, but there's no database storage or anything like that. The cookies that we use contain encrypted tokens so that the solution is easy to manage. You also need to configure your API gateway with a plugin, an OAuth proxy plugin that Jonas described earlier. So we've got some instructions on how to do that, and we'll be adding support for further gateways, as Jonas said as well. And there's a bit of a code update for developers, and we've got a code example and tutorial that developers can follow to do that. So the steps are quite deterministic, and it's primarily a deployment job.
So this answers one of the questions here. If we lean towards storing the access token inside the same site cookie or storing the access token in the distributed cache system, such as Redis. In our implementation, we're storing it in the cookies, so it's completely stateless on the back end. But of course, it is possible to consider other mechanisms, but we determined that that was not necessary.
Yeah, personally, I've never quite liked that sort of solution where you have to build your own token stores. I think sometimes they can become a bit of a vulnerability or add complexity. So I think we do some clever compression and encryption and stuff to keep the cookie sizes pretty small. And we've tested this with, RS-256 JOTs. So unless you have very large JOT payloads, then we think you'll stay under the 4 kilobyte max header limit, and the max overall cookie size is under the 4 kilobyte limit as well. So we don't think you'll have any problems with your browsers or HTTP hosts because we've verified all of that many times. So we've had a few questions.
Kind of also answers another question if the encrypted cookie contains the access token, or does the cookie contain information that allows the proxy to generate the access token?
Right. So exactly. So the access token is encrypted inside the cookie, and that is key to the stateless part of this. We don't want the proxy to generate tokens because the trust is still pointing towards the issuer of the token, the authorization server that issued the token. There's a few more questions here. Jonas, do you want to grab them?
Yeah, does the agent have support for OAuth token exchange as well, like RFC 8693? Right.
Now, currently we don't. In our implementation, we don't think that is necessary. But of course, there could be use cases where that makes sense. But typically, since it is the client right away, and it depends on what OAuth server you're using, obviously. If you're using Curity, I mean, the tokens can always be shaped to what is necessary. If you're using something else, there could, of course, be a need to exchange the tokens in some cases, but the agent doesn't do that at the moment.
I think usually with our solution, the client gets the original token, and that's what the SPA would send. And then if you wanted to do token exchange, you do it a bit later in the flow, like, an API might use token exchange to get another token to send to an upstream API, something like that. So we've got those kind of capabilities, but as Jacob said, we've not implemented them in the OAuth agent at the current time.
So a few more. Yeah, go ahead, Jonas.
Yeah, maybe this can come up a little bit in the demo. Maybe we can answer it first, but you might show a little bit of this, Gary. One of the questions is, do we need a single OAuth agent per SPA? I.e., do we need, is there a one-to-one relation between the single page application and an OAuth agent? Meaning, if you have 10 different single page applications, do you need 10 OAuth agents?
Yeah, it's good. That's a very good question, actually, because it's a design pattern that scales, but we do have some tutorials and some articles on this topic. But it's typically you need to keep, because you're different SPAs, it sort of depends on the relationships you have with the SPAs. But if you've got independent web domains, they will each need their own independent cookies. So it's very much depends on your web domains and how they're configured. And usually what we say at Curity is if you've got two different single page apps and they represent different business areas, they should get completely independent underlying tokens and therefore use different cookies as well. And
Right.
so it's very much the cookies just represent the token, so they represent the OAuth scope of the tokens. So
But worth noteworthy, I think, is that from a deployment perspective, in our solution, you only need one deployment, but you can configure 10 applications, 10 agents in there.
That's it.
So it's still just one deployment that would be required.
Absolutely.
It's kind of multi-tenant from that perspective, right? I mean, it's like you have multiple instances, but you don't have to have multiple deployments of the token handler as a whole.
Right.
So ideally, and sometimes it depends on the gateway and its capabilities, but ideally you deploy the OAuth agent once, as Jacob said, and then you have a few different OAuth agents running alongside each other. And in the gateway, you deploy the plugin once, and you have different routes that you configure as well. And there may be some differences between gateways depending on your exact hosting, but the way we've developed it in the product, it fully supports that. It may depend a little bit on your hosting environment. So. But I'm going to do the demo and hopefully that'll make some of this clear. And the only thing I'm going to show in the demo is the admin UI. So if you're new to the Curity, the token handler from Curity, what you would do first of all is you would generate a configuration. So you do that by spinning up a Docker image, and then you can log into it, and there's an administration interface. And you need to get a license, so you can get a trial license from our developer portal. And then there's something called a basic setup wizard, which gives you a configuration. So I'm going to run it. And there's two main options here. So if you've got your own authorization server, imagine you're using, I don't know, Ping Federate or something, you would choose the token handler only option. But I'm going to use the all options thing just so that I can show you all of the variations. So some of this setup here is specific to the Curity identity server, which so what I've done is I've done that and it's generated a configuration for me. So there's an entire authorization server here, which I'm not going to show you. What I'm going to show you instead is a token handler specific. So there's something called an applications profile. And this is where you create your token handler applications. And as Jacob just said, you can have more than one of these. So imagine you've got a single page app that runs at example.com or somewhere, then you might call it example. And then you get some applications in here. So as you can see, you could have more than one. And for each one, you can configure some settings. So I'm going to go through a couple of variations here just to show you roughly how this works. So firstly, you might, if you have your own existing authorization server, then what you would do is you would provide the base URL of your single page app. So this enables, for example, us to validate, so we can use this for like cross-origin request sharing or something to validate the web domain. And then if you've got an existing authorization server, these settings here will be very familiar to you: client ID, client secret, authorization endpoint, etc. I'm not going to fill them in, but anyone who knows OAuth will already have these values. So your technical teams will know what those values are. Another option is to use the Curity identity server, in which case you can create a client here. So I'm going to create one called SPA client. I'm going to give it a redirect URI, give it a couple of scopes. I think for a real deployment, you would have your own custom scopes in here as well. I'm going to give the access token a 15-minute lifetime and 2 hours for the refresh token. I'm going to create that. And so that's all of the configuration generated. Actually, there was an option there as well. So I'll show you that again, called use financial grade security as well. So this enables you to use some of the latest protections for browser requests, like push to authorization requests, advanced standards. So the thing to understand is that the most cutting edge OAuth standards are possible for your single page app. So that's the OAuth agent configuration, basically. It's if you've ever used, for example, a website OAuth technology stack, you'll be very familiar with the settings it requires. And the second part of it is the OAuth proxy. So we don't deploy the OAuth proxy for you because it's a gateway plugin, and we assume that you already have an existing gateway. So the way that this works is that we give you some OpenSSL commands to generate. I've got one I did earlier. So if I open this in an editor, there's a public key here somewhere. If I can find it. It wants to load. There you go. And machine is being slow. Just minimize that. And what I can do is I can upload a public key. Give it a name. Now, I'll explain broadly what this does in a second. And then there's a particular type of a proxy you're using. So to actually get so what you do on the OAuth proxy side of things is you configure an encrypt. So you create an asymmetric key pair in effect. And what you do is you configure the public key here, and you configure the private key in your API gateway against the OAuth proxy plugin. So the OAuth proxy plugins are downloaded from our developer portal, and there's a README file and detailed instructions, and also tutorials on our website on how to get integrated. And so you follow those, and you configure the private key in the API gateway, and there's a public key that remains here. So if I commit all of this, that's the configuration finished. And the result of all of this is you get a configuration file, and you deploy your configuration file along with the Docker image, and that gives you your OAuth agent. When it comes to the proxy cookie, this is the important cookie. The proxy cookie is the one sent to your APIs and routed through a reverse proxy or API gateway. And this uses this is the proxy cookie. This is the access token in effect. And we use some asymmetric cryptography to ensure that only the API gateway, only the OAuth proxy can decrypt that cookie, because that's the important thing, is the API message credential, and that's what we need to protect the most. So as I say, there's some instructions here you need to follow, and some gateway work and some deployment work you need to do in your gateway to get this all working. But there's quite an organized way of doing it, and then you can deploy, as I say, your configuration and the Docker container together. And
Yeah.
and we do have
yeah. So what we're saying is essentially there's a few things to cover: the agent configuration with the domains and what type of client, of where that client is, if it's in Curity or if it's in another server, and then the proxy configuration, which is essentially just saying, how do we encrypt the cookie? And we don't generate the key because we don't want the private key in the agent. It should be only on the other side. So that's why it's not generated in Curity, but instructions are given instead, so that we don't, copy keys unnecessarily in places where they shouldn't be. So just sanity, regular cryptography sanity, like that.
Right. So that's the demo. Hopefully gives you an idea. And obviously, we don't end there. On our website we have a number of tutorials and code examples. I may have a quick look at them in a minute, but I think maybe the main reason we have Jacob here is to answer any questions people have around the product, its support model, any technical questions, any scalability questions. First of all, did that answer the scalability point of multiple SPAs? So what you would do for multiple SPAs is you can configure multiple OAuth agents, and you would configure multiple routes in your in your API gateway. And if you do have large setups, there's various ways in which you can scale the use of this across multiple SPAs. So firstly, each web domain needs to sort of isolate its cookies from other web domains, which is kind of natural anyway. I think it's just part of your deployment designs. So if you've got one site at example.com and one site at acme.com, they can't share cookies because they're in completely different domains. So you would have to have two different OAuth agents. But I know there's some setups these days, people do things like micro front ends at different paths and that sort of thing, and they could share cookies if they needed to. So it depends very much on how you scale this. Depends on which SPAs you have, which business permissions they have, whether you've split the SPAs up just for code size reasons or because they have different privileges. So
I think you mentioned something interesting there, which probably relates to the auth guards question as well, a little bit, which is the micro front end pattern of having various parts of your single page application be responsible for different parts of communicating with the backend and how they're structured in code and whatnot, how they're loaded, so on. But if you back up a little bit and think of this as a sort of defense against cross-site scripting, then the micro gateways, the micro front end sort of pattern does not add any sort of protection against that. If your script reaches into the browser or some malicious script reaches in there, they can do whatever, no matter how it's split up. So if there's 1 token or 5, that doesn't matter from a security perspective. So that all of that can be exfiltrated or is under attack. So you don't necessarily need to split up and have multiple access token going down. That's more of an architectural perhaps nicety than a security benefit. I don't see any sort of real security updates on that. So that's probably a little bit in the realm of the auth guard question, but it's also one of the question was auth guards can use claims returned by the BFF or by the OAuth agent then in this case. And yes, absolutely. So the OAuth agent does not only have the token, it actually can also return claims that were received in the ID token from the authorization call. So that is decoded and can be returned as JSON to the site by just the single page application calling the session API and getting to know those things. And obviously the SPA can also call the user info endpoint. That's just an API like any other API. So you can make that call and get user info responses if that's needed.
Yeah, so probably above all else, what the token handler pattern does is it separates concerns and gives you choices, but you still need to think through your web isolation and the threats, etc. And so for example, if you had an app and its code size is getting quite large and you just want to split it into micro front ends, that's probably okay. But if you've got different business areas in the same domain, that's probably not okay. Is my opinion on this anyway. So
yeah.
Just as Jacob said, it's thinking about the cookie privileges and the cross-site scripting threats as a unit, really, so that you separate your web domains so that, for example, a low security app shouldn't be able to impact a high security app.
Right. So we have 2 questions related to the name or the word of BFF here, the backend for front end. Why did we pick that name, or the BFF pattern has a different meaning traditionally, and it's a pattern of architectural separation and tightly coupling between a backend functionality and front-end functionality. And it's not us picking the name, to be fair. It's coming from the security BCP of the IETF, which is part of the OAuth working group work that is being published. And it names 3 different patterns of how to secure single page applications specifically, and the BFF pattern is one. We combine that with the full token handler sort of structure, so that's why we call it the token handler in general, but the BFF pattern comes from there. And it refers to it being a custom client in a sense for the backend. I mean, it does a very specific task, which is OAuth client backend functionality, but turns out that's the same in every single page application, so you can reuse that. And that's why this becomes a very useful thing in a product such as ours, because then you can just configure many of those for each and all of your applications and reuse that pattern. But that's where that name comes from, BFF.
Yeah, we got some more specific questions. Is it possible to blacklist the token on the proxy side for like emergency session termination?
Yeah, so that's interesting. I mean, anything that you can do in regular OAuth, you can do here, because the cookie is really just a transport mechanism to get the token to the gateway, and then the gateway will decrypt the cookie to extract the token, and then regular processing of that token should take place. You should validate the token in the gateway. You should, perhaps exchange it for an internal token like a JOT, or whatever you do is normal. Like the phantom token flow is nice to combine with the token handler pattern, where you have one small opaque token on the internet, and then you exchange that for a JSON web token inside your network, so that your APIs don't have to call introspect. So all of that, which also then goes for revocation. So if you have a cache layer in your gateway where you handle revocations in the gateway, you could do something similar, or you could do blacklisting of tokens, or however do it. So that's kind of sort of on the side of what the pattern provides.
Yeah, we do have a separate
which
document on that called session management, don't we? So
oh yeah, exactly. There's a
very detailed document.
Paper.
Yeah.
Kind of leads into the next question a little bit, right? Do you have any metrics or sizing and benchmark that we can share? It kind of depends a little bit on, well, what metrics and sizing. I'm assuming it relates to the cookies here, but it kind of leads into what you mentioned, Jacob, around what kind of token are you actually issuing? And are you issuing a JOT? Then that's going to be a much larger chunk of information, right? But if you actually combine it with a phantom token pattern, you would probably issue an opaque token that's encrypted inside of the cookie, which is going to be extremely small, right? And then you do an exchange in the gateway. So it kind of depends a little bit, but
it does. And I don't have the numbers in my head, but we have tested with various types of tokens and sizes of tokens. And obviously, if you make a very big JOT, you could hit the limit here. But you do have to put quite a lot of stuff in there in order to do. Another thing that affects size is obviously what kind of signature mechanism you're using for the JOT. If you're using RSA, or if you're using elliptic curve, that matters. The signature of elliptic curve is a lot smaller. We chose to go also with the elliptic curve for cryptography, which produces smaller results in the end, smaller keys and all of that. So there's that, but we haven't. If you're using fairly standard type tokens with common claims and common sizes and their JOTs, you're not close to the 4K limit specifically. But in general, I mean, using opaque tokens puts you in a safer space like that. Right.
Another question is, how does this compare to a solution where the tokens don't leave the server and the SPA is authorized with a regular session cookie?
Excellent question. That's exactly the point. So with this, you kind of get back to traditional website security, which is cookie-based sessions against the backend that maintains confidentiality because it can hold secrets in the backend, and that doesn't have to flow to the front end. So that is exactly what we're trying to achieve here, that you are now, with the token handler pattern, you kind of pull up and are at par with classic website security, which is pretty much what you can achieve in any site today. There's nothing that can go beyond that currently. There are techniques in the works, but nothing that works in general browsers today for doing this. So this is not putting you above regular website security with session-based cookies and so on. This is putting you on par with that, which is a big step for single-page applications, because up to now it's been really hard to do that, and you've been kind of leaving security out as an afterthought and leaving it out there to be solved later. with these risks at play. But now with a small generic backend, you can solve this. So that's what the token handler does. So it really brings you just back to where we should be, and hopefully we can see other improvements also on that further on.
Yeah, and what I would say is that it's sort of designed based on our experience of what works well for SPA developers, and obviously there's a lot of security here. You know, we implement the OAuth flow, including some fairly advanced bits. But like I say, it's the whole experience is part of the solution as well. So you know, you should be able to avoid expensive mistakes and things that you know, get things right first time, we hope.
Yeah. Another one.
Gary,
Go ahead, Jonas.
you mentioned developers there. Gary, sort of spawn developers. So one of the questions: how do you manage the token handler then for like on a developer computer, developer environment?
Yeah, it's a bit
Given that
tricky.
you have to go through like a gateway in this case and whatnot.
Yeah, yeah.
So,
Yeah, it's a
can you
good
touch on
question,
that?
and I think that what we kind of recommend is I'll actually show you a couple of our website resources here actually, because we've got some. So we realize this is a bit tricky for single page app developers to get their head around. So we've got for example, a how to here on the stuff that I showed you just now around configuring a token handler. We've also got, you know, code example here and a deployment example. And a deployment example kind of runs on a development computer, and so developers can run all of that end to end, understand everything that's going on, and that gets them up and running, and they see how everything works. But as well as that, what you can go a step further and you can actually deploy, you know, if you're working with cloud systems these days, you can deploy the OAuth agent and OAuth proxy to support development, right? So what that means is you have a deployed domain that all of the developers use when they're doing their development work. And that deployed domain, whatever it is, you create a sort of alias to it on each development computer, such as www.mydeployeddomain or something. And all of the developers run their single page app development using the correct security with the token handler component deployed to the cloud. So as part of your deployments, you should definitely plan a productive developer setup like that. What it will mean is that your developers can carry on developing productive single page application stuff. So there's no impact on your times to market or anything like that. And you know, developers are running closer to a production setup will find more issues early and so on. So that's what we recommend. You can get started with the Docker-based setup we provide and then deploy to a cloud system or something, where it's quite easy these days to spin up a domain and give it an A record or something that points to the deployed OAuth agent and OAuth proxy.
Yeah, I think we have time for one more question. We're coming to the end of our session. I see Amit, the question, token handler can be a bottleneck for active architectures, question mark. I would say actually the opposite, because of its sessionless architecture, it really scales well over large deployments and even cross clouds. Obviously, it's a DNS game to some extent here. So given that, I'd say it's quite suitable for that type of deployment. But we're obviously in general interested in feedback of this. Please try it out, kick the tires, let us know what you think. As usual, we like to have close collaborations with our customers and anyone using our stuff. So reach out, and we'll be happy to hear you out and explain more or go into deeper details of whatever it may be.
Absolutely. I think we'll continue to improve this, and I think that feedback's really valuable. So
great. So thank you, Gary and Jonas, for taking us through this.
sorry, no, I didn't mean to bring my paper.
There's some
you go.
resources, quite a lot on our website around this. There's white papers on single page application security in general, which is very interesting to read, dive into the topic, and architectural overviews, documents on how to do this in various ways and how it works in detail. So Curity.io/resources is where you find most of these things. So thanks for joining and have a nice
Yeah,
evening.
thanks everyone for joining.
Thanks, everyone.
Bye.
Bye-bye.